Okay, let's go to third spreadsheet named exponential smoothing. As you saw, the simple moving average and weighted moving average, this moving average, one of the major drawbacks is that it has to carry the large amount of historical data, especially the simple moving average. So in this exponential smoothing method, we do not have to carry large amount of historical data to forecast the future. What we need is we only need three pieces of information. One is the most recent forecasted value, which is ft-1 period, and actual demands that occur for that forecasted period, which is a actual demands t-1 period. And then lastly, smoothing constant alpha, which is a smoothing constant and which determines response rate. So here, over the years, the exponential smoothing method has been well accepted because there are many different regions, but a couple of them are here. Exponential models are surprisingly accurate. It provides or generate a very accurate result, and little computation is needed. And the computer storage requirements are small because it does not have to carry a large amount of historical data. And when you choose the smoothing constant alpha, by the way, the alpha is determined by the nature of the product and the top managers, their prior experience. And this alpha determines the level of smoothing, whether it follows the trend or smoothing the response, and speed of reaction, this difference between forecasting value and actual value. Okay, so this is the formula for exponential smoothing. The ft, say current value, equals ft minus 1 previous value plus smoothing constant alpha, which is given in the problem, and then times the forecasting error, which indicate a t minus 1 minus ft minus 1, actual demands minus forecasting value in the previous period. And please note that you have to know the initial forecasting value, because initial value f1 cannot be computed using this formula, because f1 equals f0, but we cannot find the 0 period here. So initial forecasting value is given, which in this case is 7. So f1 is equal to 7. And using the exponential smoothing, we have 4 different periods. Here is actual demands. Let me delete. So initial value here is 7, and from second week we use the formula. So forecasting period 1 plus alpha 0.2 times forecast error, which is at minus 1, a1, actual demands in period 1 minus forecast f1. Okay, that's the way you set the formula. Then you click and copy formula to drag to the throughout the period, and you can compare these results to the when you manually calculate. The 7.6 is the forecasting value in week period 2. 7.5 is the forecasting value in period 4. Here you see the exponential smoothing only requires the 3 different kinds of data information, and you have to understand the initial value first, then use the formula to calculate the future demands. Okay, that's it. Thank you.